Additive manufacturing, which means we are taking some filament, we are extruding it through a hot nozzle and we get a nice object. Now Makera has seen that we don't have subtractive manufacturing in the shop, which means we are going to remove material instead of adding new ones. So they sent me the Carvera Air for me to check out, because today I'm going to give you my rookie CNC experience with what this system is capable of. So Makera has been around for a year or two now, and they mainly are known for the Kickstarter for the regular Carvera, which has an automatic tool changer. Now this one doesn't have an automatic tool changer. It also was a Kickstarter from Makera, and they actually did something that we don't see a lot from other companies, is improve on the design. Most of the time after a Kickstarter we can see that they are money pinching, try to get it as cheap as possible, and most of the time that means that you are going to lose out on features. Now with Makera they did the complete opposite, and they made the necessary improvements for this system to be as good as possible, because apparently this is the Bamboo Lab of CNC milling. I'm not sure if I'm happy with the Bamboo Lab of CNC. They are probably meaning that they are really good at what they are doing. A nice baggie with a manual, the spoiler boards, some tape and some instructions on how to set up this printer. Now lucky for me, I have watched hours and hours of instructional videos. They have a whole wiki with all kinds of tips and tricks on how to use this machine. First look, we got lucky, no shipping damage, and inside we can find a few cardboard boxes. These are going to be your accessories and your options that you have selected. And that's about it. It looks like we are good to go. Unboxing took only a couple of minutes. Do it with 2 people or you're going to throw your bag out. Now, the first thing I can see is I really like how they are implementing this lid design. You tilt it, you shove it back, and then it is sitting right up there. So if we close everything down, just like that, we now have a nicely closed chamber. I kind of like what I see right now. One thing I noticed is right over here, there are magnets. So as soon as you lower this down, the magnets are hugging the sides of the machine. We can see we have felt pads all around to keep all the debris inside. In this bag, we have a packing list. We have the unboxing guide. We also got a sticker pack, so we can plaster the shop with it. We have a very nice looking instruction manual. Also, the insides are looking absolutely amazing. These are one of the nicest and most detailed booklets I have seen in a long while. What I also can find are going to be these strips. These strips are actually the ones inside of the machine where the Y-axis is going to slide around. So with that, I mean these parts right over here. So they are providing you with extra backups if they are going to wear out, that you can replace them. So they already included 2 backups for you to replace them one time. Spoil boards, that means that you can cut into it. You want to cut into it if you really want to remove any kind of material out of a stock, because if you are going to try and penny pinch and just go past 0, then most of the times you will not get past the CNC milled object that you want. So you will have to use spoiler boards in order to prevent you cutting into the real boards, because this is a lot cheaper. In the first accessory box, we have a bunch of really cool stuff we cannot see in the 3D printing community, and this is actually something that I would prefer to see on printers these days. Something stupid like just an emergency stop button. Right now we most of the time have a little button or something in the menu where you can press, but most of the time if you're going to start panicking, this is going to be the thing. So we have an emergency stop, also a USB cable. This is going to be to power your tablet. There is an accessory right over here, so you can plug in a phone or a tablet and charge it that way. Some spare limit switches if they wear out your tablet and phone mount. We also have a bunch of extra shanks. This is going to be for our leveling probe, so we can make sure that everything is nice and flat, and if it isn't flat, it can compensate for it. We also have a whole bunch of end mills to start our first projects. Then we also have a corner finder. This is going to be to place on your stock so you can find the perfect corner of the object you want to mill. Then we also have a very nice toolbox. Right in here we have an extra set of mills. We have also all the dowels to put in your spoil boards. We have extra screws, we have a precision screwdriver, and we also have all the tools you need to put on a proper color on your CNC bit and to change it out if you want to go higher than what it is in right now. I think we now have a 1/8 inch of a bit in that, and we can pick anything from 4 to 6 millimeters to 1/4 of an inch or something like that. So we also have our mounting solutions together with this little L bracket, which is going to hold in your work object into the CNC mill. So first of all, before we continue, we need to plug in this hose, which is going to be for our air assist. And then we have our magnetic dust tube. This should just snap in like this. So everything is ready to now power on the system for the first time. Let's flip the switch. We got some beeping. And we got our first movements. Nice. And there we have it. It looks like the machine is ready for its first run. Before we start the milling, let's look what we have going on in and outside of the machine. So first of all, we have a very nice lighting setup, so we can definitely see what we are going to do. Even when we are going to close down this lid, we can still see what is going on into the machine. From what I can see, a 1 centimeter aluminum slab. Then we also have a spoil board right up here, but we are not going to ruin this one. We are going to add the new spoil board so we can keep this nice and pretty. We have a Z offset probe, which means that this is going to probe down to this button so it knows in what position the bit is going to be in relation to the bed. We have our air assist, and right over here we have our laser probe. So this thing right over here is going to show you where it is going to cut, and it will be used to level out the material that you are planning to mill. We have a nice little slot right over here. We have a fan right over here, probably to cool down the motor behind it. A chunky X-axis right over here, they are using 2 of them, and we have massive linear rails for the Z-axis. And then this thing right over here is going to be our quick release. For instance, if you want to change out the bit, you grab your bit, you pull this thing, and now the bit is coming out. You can insert a new one, and just like that, you have just quick swapped this little bit right over here. So super handy. We have our dust extraction right over here. We also have a drag chain right over here for all the wiring. I can also see that the air assist is running through this. But if you really want to see the in and outs of this product, then I'm going to link a video down below. This man has completely disassembled this complete CNC, and his opinions were actually pretty good on the repairability and just access all around of this machine. It is all looking very promising. Right here in the back we have 2 ports, your air assist right over here and your dust extraction right over here. So I will have to print something to hook up my shop vac into this little port. The power button, then we have a port with external. This port is actually for something they have released just recently, which is going to be external dust extraction with separation. Then we have our e-stop, data and charging. So this is for the USB cable to charge your tablet or phone while in use. And then we have the data ports to hook up to your phone or tablet. So these are going to be one of those hoses. This is from Power Plus. We have an 8 millimeter outer diameter, which is going to match this port. We have an adapter on one side so I can hook it up to my air system. And then on this side, which is the side that we are going to snip off, is going to be this bad boy. So unfortunately, we are not going to use this. I'm going to snip it off and use the rest of this cable. And now I have something to hook up to my air compressor. We got our vacuum hose. I printed a little adapter in ABS. And just like that, we now have a hookup to our machine. All right, we successfully connected this laptop to our Makera Air, because right now, this is the Z-axis. Then we have our X-axis. We also can move our Y-axis. Everything seems to work, even this emergency button. Very loud, but it works. So what I'm going to do right now is pick something from the examples guide and try to mill our first pieces. Alright, we are ready to do our first milling. I have put in a single-sided PCB, so we have 1 layer of copper, and we are going to do some milling. So right over here we have the Carvera control, that's what they call it. So this is going to run the G-code through this system. It stays connected, and it is also going to prompt you if you need to do any changes. Right now it is asking me if the probe tool is inserted. So this is the probing tool. It is just mounted right here on the side. So we have to pull down on the lever, push it in, and right now it is ready. We have a button right over here to confirm it, or we can do it on the laptop. We had to change a few settings in the controller. So first of all, it is going to scan the sides. That is going to show you if you are going to screw up or not. That means that if the laser is passing anything hard, like these metal plates, you have a serious problem. So it's first going to do the scanning. That will show you if you are in the clear or not. Then it's going to probe the PCB board, because PCB boards have the tendency to warp around. Already doing great. Forgot a clamp. So that will also mean that the depth of cut is going to be compensated by the system, which is actually a pretty neat feature, because these PCBs are very thin, and yeah, going too deep or not deep enough is going to cause you some issues. So we are going to do the probing. I'm going to leave the hood on so you can see what is going to happen. Scoot you a little bit closer, and after that we have to close it down, because we will do some actual milling. Now it will do some calibration on this button. Even the laser gets calibrated right over here. So this is the scanning moment. We are now seeing the outlines of what we are going to mill. We can also see that the probe is flashing. That is when the probe is starting to make contact, and the flash is just a confirmation. Not sure how the probing is working. It could be that they are using the light flashes to do the actual Z offset, because light is faster than a mechanical switch. The probing is done. Now the system is asking to insert tool number 2. I have them right over here. These are the tools that we are going to use. So I will change out the tools. The only thing annoying right now is these are in boxes. They are calling it tool number 2. You have no clue what tool number 2 is, unless you have a little box right over here that you can set them. This is mainly used because they also have an auto tool changer, which is not present in this unit. So I'm going to figure out which is tool number 2, and then we can replace the probe. This is a tool right over here, and as you can see, there is no collet on this one. So we have to install a collet in order to make this all work. So for that, they are providing you with spare 1/8 inch bit collars. We are going to grab one. Then we need our collar remove and install tool. Inside the install tool, there are a few pieces. We need to remove this piece because we don't want to remove a collet. And then there are also 2 cylinders. You will have to remove the smaller cylinder if you are going to use bigger bits. And now by turning this, we are going to push the bit through the collar, and we should have installed it in the perfect position. And there we have it. Our bit is installed into the collar. Now we need to install our tin-coated corn bit. So I put the number 3 on it, so just I remember that this is now on number 3. Funny enough, this one has a collar and the other one didn't. Huh. And it is looking something like that. This will do all the cutting of the PCB board. Now we can remove this board because this board is ready. This is our completed PCB. Now, normally you would add a mask over this so we don't short out over other components. In this case, they didn't provide the PCB masking kit and the laser. So what we are going to do is just continue with the build because we can do it without the mask. So the dust extraction seems to be working very decently. We only see very minor amount of shavings around the PCB board. Depending on the vacuum that you have to power this thing, you have a very good experience even with PCB material with a copper layer on it. Now I have to say the cuts are looking extremely clean, so this is very good news. Now, like you can see, we have a tab right over here and we have a tab right over here. Now we need to grab a saw and cut this through so we can release this PCB board. And for that they have provided this mini handsaw. This is to cut everything with a little tab on it. Here we have it, our very own milled PCB board. You can also see we drilled out the holes for all the true components that we need to solder from this side. And right over here you can see it the best. The dark layers are the copper. The white layers is where we removed the copper, because basically what we are going to do is isolate the copper patches from each other so they don't short. And this way we can create traces, and these traces are going to power some LEDs and other functionality. But before we do that, we need to mill some other stuff. And here we have it, our first ABS milled part. This time we also have our first real chunks of material, not like the previous time where we had dust. This time we have actual plastic chips. Also interesting to see is that chip evacuation or chip extraction with the dust vacuum hose thingy. Not really that great with ABS. We have a lot of static electricity going on, and we can definitely see it because everything is plastered with ABS. I already did a very fast cleanup on the first passes. This time it was better because we were cutting deeper. So let's clean it up real quick, get this out of the table and see what we are working with. The surface finish on the sides seems to be a little bit rough. Maybe this is something we can tune out on other milled ABS parts. Now let me clean up this side and let's do the next part of this build. The protective film is still on the back. The instructions tell you to remove it, but first I'm going to remove this piece. Gave it a little push and it just snapped off. So it seems to be the case that we needed to snap it off. Now removing the back protective cover. So in my case I have chosen to mill out the Spider-Man one. It is looking absolutely great. The sides also seem to be really good milled. Yeah, really like it. This is a very good engraving so far. Next up will be this aluminum plate. Not sure what type of aluminum it is, but we are going to mill out a button out of this. So this right over here is super cool. We can see that we have some sort of a color code. We have 3 and then 1, 3, 1, 3, 1, which means that you have to install bit number 4. I labeled this one. This is going to be bit number 4, a single flute bit for metal. So what we are going to change is I'm going to hook up the air hose and we are going to do our first air assisted milling, including this bit. Let's install this, hook up the air hose and do our first aluminum milling. All right, the bit is in. Let's close down the top because we will need all the protection for the flying spanners. All right, I got my air hose ready. Wait for the first chips. And there we go. Let's put on some air. And now all the chips are just flying away. All into the chamber. But that's okay. Right now you also have a better view of the cutting. All right, there we have it, our first milled aluminum. Now, one thing I figured out during the waiting was the following. Look at this, we are missing a magnet. So, found this right over here. We lost a magnet. As you can see, we only have one more magnet. So, a little bit of super glue. If this is going to be my biggest concern, I will be very happy. Pressed it back in with some super glue. It is already sticking. And there we have it, our first milled aluminum. Let's home it to the front so we can actually see what we are doing. So right now I'm actually pretty impressed with what I'm seeing. This is obviously also the first time I am getting my hands on something that is capable of CNCing in the first place. Even better so with aluminum. Yeah, you already got me way hooked on this stuff. This is opening so many doors already. And if you are planning on buying this, I would definitely recommend you to try out the sample stuff that they are providing with you, because this is absolutely the best way to know your machine and how to work with the, I would call it a slicer. It isn't, it's the controller. The controller is only pushing the sliced material to this CNC machine. But I have to say that even now, looking at the surface quality of the milling, I am very impressed with what this machine is capable of. Now, I am missing the laser. I'm also missing some of the PCB stuff. So this is probably an in-between model. So between the $2,200 and the $3,000 one. So this is probably the $2,500 machine, including all the sample material for you to try it out, like I'm doing now with the LED light bundle that they are providing with you, together with some other stuff like the 4th axis, which we are going to try out after we have soldered all the components to this board, freed this little aluminum button from its cage, and see if we actually made something that works. All right, let me move this out of the way first, and I will circle back to you when everything is ready. Alright, you have just seen me mount and solder all the components. This is the board that they have provided with me, and this is the board I milled myself, soldered myself. I have to say, not my proudest moment in soldering. For some reason, the soldering station I have right now never provided me with very good solder joints. So I might switch it out with one of those stations. You can actually also do some hot air kind of stuff. But yeah, that's for another video. So what I'm doing now is putting in my own board without the mask. The mask has not been provided with my kit, but what did arrive was the laser. Yes, sir. We are going to do some lasering. Last little bolts. So we have our metal button. We milled ourselves aluminum. We have our base. We made our own PCB board. Now, let's put in this little feller right over here. The only thing we need is a USB port. Got the USB port. Let's plug it in. And there we have it. We have our own freaking light. Look at this. And it also is active to the finger. So which means if I keep pushing it, it dims all the way down and it gets bright all the way up. This is such a cool project to do your first milling and just try out all the features of this printer. So we can see we have a successful first project. Now, the next project is going to be another sample project. This is going to involve what they call epoxy boards. Now this time, instead of using the preset G-code in this machine, I'm going to make something else. It is definitely not included, and it is going to be involving some of my favorite movies of all times. But instead of telling you, let me show you. Big moment. Epoxy board is in. We did the same thing that they did in the manual. Only thing is we changed out the picture, which meant that I had to use the CAM software that is going to be delivered with this machine. It is simple enough, but I do recommend you to go through all the freaking videos that they are making. You really need it just to basically understand what the hell you are doing, because otherwise, yeah, this is not going to happen. So it worked. On the laptop was struggling really hard, so I do recommend you to have some sort of a computer with a bit of horsepower in it. But we got it in, and this time, fingers crossed, everything is going to work. I have my emergency stop button with me. I'm going to scoot you closer, and if we are going to break bits, and are we going to crash? I guess we'll find out. So here we have it. This is going to be my little lithophane. If you don't know what a lithophane is, this is commonly used at the 3D printing culture. Now, what the hell are we actually looking at? For that, we need to make the room dark and put an LED light behind it. So this is it without LED light. And now if I shove this behind the frame, and there we have it. We have Darth Vader fighting the mega alien xenomorph from the movie Alien, of course, with its little alien brothers right over here. This is absolutely super cool to see. Now, the only thing I can see is right over here, there should be a sword. Yeah, the sword is gone, but you have to use your imagination. This is so cool. Next thing we're going to try out is going to be the 4th axis milling. which means we have a rotary device, this right over here. So what I'm going to do is clean everything up, install this rotary device, try to load something custom in there. We're not going to bother with the install G-code, that's not cool. Very, very solid. This looks to be new. They have made some kind of a housing cap to protect the stepper inside. Also something they did in a revision is try to get away with the backlash, something with harmonic, I forgot how it's called, but yeah, we can absolutely feel zero backlash on this machine. Completely milled out of aluminum or stamped, not sure. And yeah, what we're going to do now is install it right over here and do our first millings. Got the fourth axis installed. I also installed this little block right over here. And the next thing we need to do is load up the G-code and then try to see if this is going to work. Also this time, I'm going to keep this very close to me. First attempt has a little bit of a fail going on because the spindle and the collet right over here is hitting the sides of this block. If it's going to turn, then we are definitely going to get some collision problems. Biggest problem is right over here, the spacing between the model and the ends of the block. This right over here is not big enough. So I have done some reprogramming. This one is trash. I'm going to replace it with the second block we got right over here. And we're going to try that again. Another thing I found out is this arm is ready to fall off. Yeah, this is the second time I'm going to tighten it. You have a grub screw right over here. You have a grub screw on the other side. You have to pull out this arm and then you have a bolt. So we have to put some Loctite on that bolt because, yeah, this is not great. So here we have it. This is a 4th axis milled alien bust, and this is also going to be a great example of what the limitations are going to be on the Carvera Air. This right over here should be hollow. Same thing with this, same thing with this. So we can definitely see that the 4th axis will only be milling this way. So it will not move left to right and try to punch down and make those cavities. It is only going to mill and the 4th axis will only turn around. So this is actually a pretty dumb setup, I would say. Apparently there are applications that you can move the y-axis while rotating and all of that, so you can create those pockets right over here. But Makera is not doing it. I think the paid version of Fusion 360 enables this function or feature, but yes, that's out of the scope of this video. So with Carvera, this is going to be the stuff that you will mill out of a solid piece of epoxy board. Alright, here we have it, the fruits of our labor. We have done over, I would say, 100 hours of milling. We started off with the project that is inside the Carvera, so the bundle that you're getting, there is some code that they pre-made for you, so the G-code, so you don't have to program anything, you just have to clamp your material and then you can just press a few buttons and it will do the things just like this lamp right over there. So that was my first experience. Everything went pretty uneventful. Then, because Noizie works, we are not taking the easy route. We started to side quest on everything we have done. We started out with our own designs, with the materials that they have delivered. And I can tell you one thing, my appreciation for people that do CNC at home or business. Wow, I have a newfound appreciation for you guys because you have so many things that you need to take in account if you don't want to screw up the things that you're going to mill. Now, this is not the fault of the machine, this is just me being in an office and we had one massive failure, which I'll be talking about when we get to that project. But yes, so we have tested all the things. We have tested the light thingy, then we also started off using the laser. So this is going to be the model of the laser. We have used the, subscribe. If you're not, make sure that you are. We did the lasering on the edges. Now the subscribe part was also lasered, but I cut it off with the chamfer. My first problem was, the depths were not what they needed to be. So I chamfered off basically all the lasering going on, except for these edges. But like you can see, the quality of this part is still pretty amazing. We screwed up a little bit, but we can see that the laser is working. Now about the laser, you are getting these fancy little goggles right over here. These should protect you when you are using the laser. Now I'm going to turn it off because I get a headache from it. The problem is, the laser has a little shroud around it, which is not a problem. This is a bit of a safety feature. Now, while the shroud only is not safe enough in my opinion. The top lid of the Carvera is transparent. It is not made of a material that will hold back the laser beams. So if anything, because of your own doing, you are clamping something wrong, for instance, one of these brackets you mounted wrong or your G-code is not correct and the laser is passing over this part, it could potentially reflect through the top visor into your eyes if you are not wearing your eye protection. This little shroud right over here is not going to save you for your life. You really need to use those goggles. If you don't, that's on you. This printer, in my opinion, is not safe enough to use a laser. I would like to see something dedicated for the laser, which means that everything is hermetically closed, so I feel safe around it. Right now, it is up to you for your own safety. Now, Carvera has made its decisions. They do provide the safety goggles for you to use, but we all know after a few days, weeks or months, the tendency to leave this off are going to be pretty high. Don't. That's all I'm going to say about it. So this laser has an air assist, which means it is going to blow air on the project while it is lasering, cooling it down, potentially putting out fires if the project is catching fire, and generally are going to give you much cleaner of a laser engraving if you are going to blow some air on it just because the material is cooled down. So pretty neat. It just pipes into the side where the air assist is if you are doing anything else. So this is a 5-watt laser. You will be able to engrave pretty much everything that is not transparent. Cutting is going to be very limited to cardboard and that type of materials. But if lasering is something you are interested in, this is an optional extra you can buy. So this is my attempt of a relief cut. This right here is a lithophane I have imported into the project. A lithophane is something you can import a picture most of the times into a piece of software. In this case, it's Litho, I think. I will put the name of the software right over there. You upload the picture, you get an STL out of it, and then you can carve it out with the Carvera, or you can 3D print it. But this is just a 3D STL, so it's definitely possible to make lithophanes. Super interesting relief cutting for stuff like that. If you are into 3D printing and your lithophanes are a little bit too hard to work on. So this right over here is definitely super cool to use. Then we also have used the 4th axis. We have a stepper motor in the back. We have some harmonic kind of gearbox in here. And then we have a chuck. And on the other side, we have our stock. This is a rotating thingy with a little clamp right over here. And this is just to center your object in the middle and provide another support point for you, because this is also a relief only kind of cutting, which means that the x-axis will move back and forward, the y-axis will stay stationary, and this chuck will turn around, so it is actually doing what I would call a 2D type of cutting. The third axis, the Y, is not going to be used with this, which is unfortunate in my opinion. I would love to see this axis move back and forward. Now in the Carvera CAM software, this is not going to happen, but apparently if you are using software like Fusion 360, you should be possible to do all the things. So move the X, Y, and then use the Z plus the rotating mechanism of this material. So that is going to bring me to the LED right here in the back. This is now powered by the CNC itself. So there is a port in the back which is saying charging. Now, is the port working? Apparently so, because this light right over here is plugged directly into that port. It seems to be working pretty much fine. So you have a little bracket you can mount on the sides. You can put your phone on there or a tablet or whatever you want. And then you can use the Carvera controller to see what is going on, pause the system, load G-code and all of that goodness. Now so far the Makera CAM software has been working pretty much flawless, until I decided to do another project, which is going to be a little bit of a test piece for the next upgrade video for the Go Live that we are doing. We are making our own dual plates and all of that goodness, which is going to be this part right over here. Let me tell you something, the Makera CAM software did not like this project. This is a step file that I imported into the software. We crashed a bunch of times just trying to import this file, and then we also crashed a few times just to try and generate a toolpath. Also something fairly weird was trying to select one of the holes, would select the backside, and it would basically mill away all the material. So I used that same step file in Fusion 360. This has been milled out with the Fusion 360 software, and that worked flawlessly, except for my own stupidity, which is going to be next. You need to be very careful. So TLDR, the Makera CAM, it works, but on the more complicated parts, it seems to be needing a little bit more work. Now, normally when we are seeing something like that, I would get pretty mad and it would make a big stink out of it. Now in this case, the software is free with the CNC that you are getting, so that is already a big kudos these days. We have a bunch of subscription services. Now they have provided it for free, but we can see the software needs a bunch of work for me to be able to use it reliably. Now Makera also has a bunch of profiles, so they can vertically integrate in any CNC controller software that you want, which means you can slice. It's basically the same as 3D printing slicing. You can slice your project on any software that you want, and they provide all the files for you so you can import. So in my case, for Fusion 360, they had all the profiles to import in Fusion 360, so I could just bypass the problems I had with Makera CAM and just use Fusion 360. Now, Fusion 360 has its own problems. If you want to use multiple tools and you want to do the tool switching, it is going to complain to you that you are using the free service and you have to export these files separately because you are not a paying customer. And let me tell you something, that software is going to cost you over 700 euros a year, or you have to pay a bunch of money to get a full featured piece of software, or you have the free stuff, and then it's going to be a little bit janky. Now, back to this project right over here, we have screwed up big time. Let me show you what went wrong. So this is a 6mm end mill with a ball nose on the end, and yeah, this is going to be our first fail. So this block right over here was sitting in this corner, and we had one problem with the laser. Normally you are probing your material on top and then you do all the tooling that you need to do. Now, unfortunately, because we were a few steps ahead, this probe, instead of touching the top side of this material, because we had a cutout right over here, instead of probing the top side, it probed the top of the very thing that we were carving out, making this bit plunge straight to this object, sending this bit all the way down until we hit the aluminum plate. And then we got a fault from the Carvera. It shut down because it suspected that things were going wrong, and they definitely were going wrong. So we have touched the aluminum plate on the bottom, I am pretty sure, because this is sounding like metal on metal contact. So we had our first whoopsie. We have plunged all of this bit straight down onto the aluminum, and yeah, luckily for me, the bit actually survived and we finished this object. So what I wanted to try and do with these bits was trying to mill out these holes, and these are chamfered. This was basically doing the chamfering. And right over here there was also a hole, and instead of just doing the hole, it plunged all the way down, creating a big ass mess. So yeah, completely and utterly my own fault. I didn't watch the system doing its probing. I didn't realize that the probe was not touching the top side of the material, because in your software you're going to select how big and how high your material is you want to mill out. But if the probe is going to get 50 millimeters lower than you really wanted, then this bit is also going to get lower than you wanted. I also got these corner clamps. This is going to be very handy for your materials. The only thing I have noticed is these will slip on you, which means if you're going to tighten these on your build plate and you try to turn in the screw to put some tension on your part, and this will slide out. So what we can do, depending on the material that you're using and the spacing of the bolts, is put a bolt behind it so that part is no longer able to slide out, or use the first port right over here and hope that you have enough reach for this clamp so it can't slide back. Now this is a minor complaint, I tried it, it's not a real issue, but you can circle around the problem by using bolts in the correct positions. Now we also ordered a bunch of extras, like this block right over here. This is some kind of a resin material. I think they call it wrench shape in America. This is a very soft resin-ish type of material to do some prototyping in. And I have to say it is really enjoyable for this thing to mill out of. Just like this right over here is, I think you guys call it Delrin. Yeah, these are very soft materials and these are super handy to test your projects on before you are going to destroy your end mill in a piece of aluminum, which is what we're going to do in the next video. So in my case, we could see we made a big whoopsie, but I could also see that everything I programmed in Fusion 360 after we did things correctly. We are now pretty sure that this is safe to mill with a piece of aluminum. So very handy. I bought a bunch of these. Now we had a little bit of a mix-up because after my order, I think 1 or 2 weeks after my order, I received these guys right over here, which what I showed you right over here, so you can use it in the same color. Now, I received the wrong parts. You can see it by the color of the ring. This one is actually blue, which means this is for the 6.35 millimeter end mills. So I got really confused. I didn't order this. Also, my clamps I ordered arrived, and then we also missed some spoil boards and all of that. And I was thinking, what the hell is going on? Because we ordered a bunch of parts, I received probably half of my order, and then this stuff was completely incorrect. So I reached out to the support with my anonymous email address, and they were actually very helpful. The first time, I think my email got lost because after a day or 4, it was pretty silent on the other side. So I answered the email of my order, said in big letters, you can just reply on that order, and they were happy to help. And then eventually we figured out this was actually a sample package they were sending me just to show you guys how the color is working. And my order arrived 2 days later with everything I ordered in that package. Then we also had a few mechanical problems. For instance, right over here, we have one of those dust shoes. This is the dust shoe that you can use. You can hook up a vacuum on it, so you don't have that much of junk flying around in the chamber. And right over here, we have 2 magnets sitting in there. And one of these magnets came loose. 1 drop of super glue fixed that, and since then it has been pretty much solid. After a while, I could notice a bit of a rattle in the system, which was actually pretty weird. Then it prompted me to change out a bit, and I could see this handle right over here was completely loose and ready to fall out. So what I did is pull out the handle. There is a grub screw in the front and a grub screw in the back. Then you can remove the handle, and then you can tighten the bolt that is holding in this complete contraption, only to see it being loose again after the next day. I think we have about 12 hours of milling in it, and the handle was completely loose again. So I did the next best thing, which was going to grab some Loctite, blue Loctite, added the drop on the bolt, and now it has been solid. We have been running it for 4 more days, and now I can see my handle is super solid, not an issue anymore. So those are 2 things I have noticed on my Carvera Air that could be done better. So securing the magnet, yeah, could be a one-off, but in my case, yeah, it came loose, and then the handle came loose twice. But except for that, the machine has been handling everything pretty nicely, and we are going to finish with some calibration projects. So right over here, we have a piece of aluminum, which we are going to use with a digital clamp to see how the tolerance is on cutting aluminum with the standard 1 flute, 0 degree, 3.175 bits, something like that. The 1/8 inch kind of deal. Yeah, that one. I'm going to state the obvious. This is not a high-end caliper, so I have no clue how accurate this thing is. This is not a Miti Toyo type of a deal, which is going to read out what this thing is going to say me. We can see that it is pretty accurate on the 0 point. So we have 3 relief cuts. The bottom one should be 20 millimeters. Yep, dead on 20 millimeters. The second one should be 15, and then the very top one should be 10 millimeters, and this should have an overall thickness of 4.7 millimeters. So I can say I'm pretty happy with the tolerance I can see right now. This is going to be it for the video. We are going to do a lot more milling with the Makera Carvera Air. If you are interested, the links will be down below. And right now they have a little deal going on. The back to school kit, which is basically going to be involving this little piece right over here. And if you open it up, they are providing you with a whole bunch of end mills, engraving bits, drill bits. Then we also have bit colors. So they are providing you with a bunch of bits for you to start out your first carving experience. Also, there will be a coupon down below, which means that if you're going to buy this system, you get an additional $100 off your purchase. The links will be affiliated, and if you don't want to use them, then just go directly to their website. So that's going to be it. As always, I want to thank the members of the channel for supporting the cause. If you are interested to see more videos about the system, make sure that you are subscribed to the channel. Consider becoming a member for $1 a month. You can support the channel for the crazy stuff that we are planning to do, like completely modding the Retric Vico 4 with custom tool plates and all of that. So big massive shout out to the members of the channel. Thank you for watching, guys, and I see you in the next one.